Howdy. In this video, I'm going to discuss logistic regression and how to use Python to do the logistic regression for us. All right, let's start. So we have a bank data, and then in this bank data, basically our objective is if this bank designs a new campaign, what is the likelihood of a person accepting the personal loan? So in the past, they have done some similar stuff. We have collected the data, or they have collected the data. They have a customer ID, their age, experience, income, the zip code, the address they in, family size, average spending on credit cards per month, the education level. 1 is undergrad, 2 is graduate, and 3 is advanced professional. The mortgage, if they have any, personal loan, if did they accept personal loan offered in the last campaign. So this is our Y variables for our analysis. Security account, if they have any, checking account, if they do online banking, and if they have a credit card with the bank. Right. So again, our job is to discuss or find a methodology to decide what is the likelihood of a person accepting a new offer and take a personal loan. So first thing is that we are going to check or load the data, but for that I'm gonna import the pandas, as we have done it many times. I might draw a couple of figures, so let me plot that one, import that one as well. Matplotlib pyplot as plt, right? And then I'm gonna import the data from a folder, and I'm gonna call this data as the bank data. And let me actually show you the data set if I can find. So this is the universal bank data, and it's an Excel file. Excel SX file. And then I can check the inside of the file. So ID, age, experience, income, seems everything is there. I'm just looking at the ages, income levels, zip codes. It looks okay, but we'll do some analysis on Python. So I'm gonna actually say pandas read, and we are gonna read an Excel file. All right. So there are two ways of reading this file. One is, let me copy the path for that folder. So put basically, let me write the path and then I'll show you. Right, Excel SX, and one way is just putting double backslashes, so adding another one, and that way we could just read this data and then enter. All right, it seems I forgot to put this one here. Right, so I read it. I can check the bank data. Data head. All right, so here's my 5 data points. It seems okay. The other method is, instead of putting 2 backslashes, using, and I'm gonna call this one data 1, and then they just delete it, is equal to pd read Excel again, right, open parentheses, r 1 2 3, and then of course I need to, all right, copy the path again, right, and this is an XLSX file, and then put 3 commas over there and enter. So I can do the same line here and say bank data 1. Right, here it is. So both of them work. So I'm gonna just clean up the memory and delete the bank data 1. Right. No, So I have this data and I kind of need to understand how this data looks like. I didn't do a very detailed analysis in the Excel when I checked the file a little while ago. So first thing is I would like to know if there are any empty field in this data set. So I'm gonna call bank data and is null, right? And that is basically checking if there is a null field, if there is any empty field here or attribute value. So if that is the case, I want to sum them up and get a report, right? So we are lucky in a sense that all the fields are cleaned up. So that means I don't need to do anything about that one, at least for now, right? So the second thing I want to check is that, like, when I look into here, there is an ID, there is this column, which is another ID basically. So I could eliminate ID or put the ID as an basically index. I need to decide on that one. There is a zip code field. Zip codes mathematically do not make sense. They are assigned to a geographic area. And so basically when I deal with them, I need to consider that one. And my solution here is just to eliminate it because I really don't know how the zip codes are related. And there are some in 5,000 or so data set. I don't want to go like assign each zip code to a region and then do some extra calculation. Family size seems to be okay. Education, securities, credit card and so forth. As we see education here, education is 112 and there were 3 the professional degree. So that is something I need to deal with because if I keep it as 1, 2, 3, the logistic regression or any regression in that manner, they will think it is just a continuous number or set of numbers. So I need to convert it to variables, right? So those are my first observation, but I'm gonna check the data a little bit more. So I'm gonna call the describe function, right? Let's check the data. Again, there are 5,000 columns. ID average is 2,505. Again, this doesn't really make sense, and we are gonna find the solution for it. Average age is 45, mean is 23, and max is 67. So that makes sense. Experience, the minimum experience is -3. So that's an issue I need to correct. And there are a couple of solutions. One, I could delete those -3s from the data set. And honestly, if that is the only issue, it's probably not a good idea to delete. So I need to find some other way. One interpretation is perhaps this is 3, not -3, and somehow there is an negative sign put in front of it. So I could do fix that way is whenever I see a negative number, I will convert to a 0. So that is what I'm gonna do actually. All right. Family size, okay. So others seems to be okay based on the summary of the data set, right? Let me first correct this experience thing. So I'm gonna write a function and I'm gonna call this function as fix experience. Right, and this function is going to get a value, and I'm gonna get this value from basically this column's experience column and then assign it to it. And if that value is less than 0, then I'm gonna return 0, basically make it 0. Else, that means basically if the value is 0 or greater than 0, then I'm gonna return the value itself. So I'm not going to make any changes, right? So that is my function. So let me call this function and correct the experience. So I'm gonna work on the bank data again, and the field I'm interested in is the experience, right? In the experience, I'm gonna say this new experience field is bank data there is a function called apply in pandas. Apply means basically apply a function to this field, right? So I'm gonna call that one, and then lambda, and I'm gonna apply to all the rows this function I just defined, fix experience, right? And then the value is the row of, all right, actually let me do this, experience, right? So let me try to explain. Lambda is a keyword. It is just fixed you, so you call it whenever you have this apply function, as far as I know. So I'm saying that I'm going to apply to the rows, like the function I'm going to call it is this fix experience. Again, this basically takes a value. If it is less than 0, makes it 0. Otherwise, it just returns it back saying that I don't need to make a change, right? And then I'm saying that you need to look into each row and then the experience column. Once you read that one, basically do that one, experience, fix experience function, applied that one, and I want to apply it to the all function column of experience, right? So when I do this, hopefully I will be able to solve the issue. Let's check the bank data again. Describe, right? So experience is fixed, so that was something I was trying to get it, right? And then the next thing is that I want to drop the zip code. I could either drop the ID or make it as an index. So I'm gonna drop the zip code, but then make the ID as a new index. Okay, let me do drop the zip code, bank data, right? Drop, right? Oops. Zip code, right? And I want to do this one on the column, and I want to keep this bank data as a bank data in terms of naming. So it's gonna replace basically itself and stay as the bank data after dropping the zip code, right? And that is done. And the next one is basically setting index. Let me do that one as well. Set index, okay, right? Just a second. All right, ID, and I'm gonna say in place. So I'm keeping this file as it is. All right, let's check the data one more time. And I'm gonna look into the header this time to see which columns I have. Right, so ID is the index now, age is there, experience, family, personal. Okay, so I eliminated the zip code from the data set. The next thing I need to take care of is this education, right? So 1112222. So and then there were 3. Basically one undergrad, 2 grad, and then the third one is the professional degrees or advanced degrees. So for that, as you know, we introduce a dummy variable, and getting dummies is kind of easy with the Python. So I'm gonna say the new data set is the bank data again, and I will say get dummies, right? All right, and then I'm saying look into the bank data file or the data frame, and then find the columns, and in this case I have only the column education that I am interested. All right, and then drop first, right? And that is true. If you remember, in this case we have 3 categories: undergrad, grad, and advanced. and then I'm gonna create n-1, 3 minus 1, 2 basically categories, right? For the right, and after creating it, I'm gonna just look into my data set one more time to be sure I have done everything correctly. Age, experience, income, family, personal, yeah, and I have education 2 and education 3. And the first one, education 1, which is basically the undergrad, that was basically eliminated as a column, because if undergrad is 1, then these 2 are going to be 0, right? So I don't want it to stay as an education 1 and 2. So I'm gonna rename them, okay, just to make sense for myself. And for that, I'm gonna use the rename function, right? That rename very creatively, right? And I'm gonna rename the columns, right? Right, this is curly brackets if you guys cannot see it. So I'm gonna say education underscore 2 is actually gonna be renaming grad degree, right? And then comma, I'm gonna say education underscore 3 is going to be my professional or advanced, let's say advanced degree, right? And I'm gonna just use that in place term again, but I'm gonna just for your guys' sake reprint it, right? So change the column names as well. So I am good to go. Now I'm ready to actually do the logistic regression, right? So let's start bringing some function for us from scikit-learn. I'm gonna do the model selection and import the train split 1. And this time I'm going to divide my variables into 2 x variables. Let me say x vars. This is x variables. Again, x variables are age, experience, income, family, mortgage, securities, blah, blah. Basically everything but personal loan. And then the y is the personal one. So I want to know if they will take that deal or not, right? So for that, I'm going to just say bank data. Of course, drop this personal loan, right? And do it for the entire column, right? And then my y is just a single variable, and that is going to be equal to bank data. But this time I'm not dropping anything. I'm just saying it is equal to the personal loan, right? While at it, let me create my training and validation data sets too. Xtrain, X validation, and ytrain and y validation, right? And that is equal to train test split. And I'm saying that for the x, use the x vars, the x variables that I defined. Basically it's gonna go pick everything by the personal loan, right? And then for the y, just choose the y variables, right? Vars. And I'm gonna also define the training data size. Let's say that is 0.6 and random state. Oops. Let's make it 2. And this way, all of us, if you are trying to do the same code at your computer, you can find the same results, right? Run it. There's this idea that there is some changes are coming. Test size, I'm defining the training size. There is a test size, so basically it says they are complement of each other, right? If I say 60% training size, 40% is gonna be the test size, right? So I divided my data. If I want to look into it, I can do it, but I'm just gonna continue. This time I'm gonna call the linear model, Sky linear model, and import logistic regression, right? Right here, and I'm gonna call this one as logit model is equal to logistic regression. Right, the last time we called the linear regression model, if you guys kind of remember that one, right? Let me change actually this name, logit model, not the logis. Right, so next is I'm going to basically call this function, right? And I'm gonna fit it x train and y training data, right? Remember, x train is all the parameter, all the attributes here, but the personal loan, and then the y is the only personal loan data, right? So let me run that one, right? Again, they're gonna change the default solver, but it's not a big deal. So it gives me some information here. I basically ran for maximum iteration of 100 and so forth. So if I want, I can change all these parameters basically for this fit objective, right? Right. So I know the model now. I could do a couple of things. One is look into the model and see how accurate is it, right? And for that, I'm gonna call the metrics import confusion matrix, right? And inside the confusion matrix, actually before doing that, let me get the accuracy score first. Right, so how accurate is these basically predictions? I'm gonna check that one and say predictions are gonna be equal to logit model that I created, right? And then call the predict function, right? And use on, okay, let's go test it for first on the training data set, like how good they are on the training data set, right? X train, and I'm gonna ask for the accuracy score, of course, while edit. And for that, I'm gonna say y train versus my predictions, right? Let's see. So it looks like when I run this model, I am accurate at 95.8%. So basically, when we say this person is going to get the loan, he or she will get it at the 95.8% probability, right? I can show you one more thing, and then we are going to switch to stat models to cover a few more things. Right? So let me do the same thing for training. I'm going to actually validation data set, right? I'm going to call this one 2. I'm still calling the logit model predict, but this time X validation. So I want to know how good it is on the validation data, and Y validation. Oops, this is not correct. Oh, right, prediction 2. Right, almost same, 95.55 versus 95.8. So it looks like this model fits nicely. to predict the result. I can also look into the results a little bit more details by calling against and metrics, right? Import the confusion matrix I mentioned a little earlier, right? And then confusion matrix, and it is the same Y validation, and then the predictions too. I'm gonna just look into the first actually on the validation data set, right? Right, in the confusion matrix, the columns are basically the predictions, and then the rows are the actual observations. So first column is no, which means basically we predicted no, this person will not get the loan, and then the answer or the actual observation was also no, she will not get it. So we were accurately classified them. Then the second column is yes, we predicted yes, they will get it, but the actual observation was no, they did not get it. So we missed 20, or we misclassified 20 of them, saying that they will get it, but in reality they did not get it. All right. And then the second row is yes. So we predicted yes, this person, we predicted no, this person will not get it, but in reality they got it. So 69 of them, we were thinking they will not get it, but they actually got the loan, right? And then 115 of them, we predicted they will get it, and then they actually got it, right? And that accuracy was 95.55. So if you add all these numbers, that is 40% of the 2,000 records, and out of those 2,000, 1796 plus 115, those we were able to rightly classify and say that they will get it or they will not get it, right? So